that one side of the road is raised and this other side is lowered. And where we have this kind of surface of the road is where the road is having curve alignment, where the alignment is no longer straight, it's curve. So this is what we call super elevation, and this is what we call camber. Now, I decided to do this video so that we can be able to handle calculating slope for camber and super elevation at the same time. So let us look at how to calculate slope for camber before we also talk about this. For camber, if you want to calculate the slope, let's say slope percentage, this will be equal to rise over run multiplied by 100. So let's play with the level given. The rise, for us to get the rise is from this point to this point. This is the rise. So how do we get the level there? We say this level at this point at the crown 46.00 minus the level at the outer edge or inner edge, which is this 45.87 divided by the run. The run, this is cross slope. So when finding the slope, you don't use both distances at the lane width, because it's sloping in this direction or in this direction. So if you're working with this, you use this. If you're working here, you also use this. So decide to use this 5 meter multiplied by 100. So we're removing this from this. We have 0.13 over 5 times 100. So this is giving us slope of what? This is giving us 2.6% slope. So let's quickly talk about the super elevation section of the road. Why do we have to make the road super elevated in curved area? When the vehicle is approaching curved area in the road, the centrifugal force tends to be higher. As the force pushing the car out from the road tends to be higher. So to counterbalance between the centrifugal and the centripetal tends to push the vehicle inward. So to maintain this balance, we have to raise one section of the road up and lower the other section. So if you're asked to calculate slope in super elevation, this is how you approach it. The slope for super elevation, say the outer, you can say outer edge minus inner edge all over the lane width times 100. So what is the outer edge level? The outer edge level is the level at this point, which is 46.00, minus the inner edge level, which is the level at this point, which is 45.00, all over the lane width. The lane width has to be the width from this point to this point, which is 10 meter, multiplied by what? 100. So we have the slope this, or subtracting this from this, here we have the level here is 45.5. So here we have 0.5 over 10 multiplied by 100. The slope. So this will give us 0.05 multiplied by 100. And this will give us 5% slope.